today we have the homework worksheet. We're just going to review that like we're beginning to do already. Section 9.5, slope-intercept, parallel and perpendicular lines. We did that on Friday. We're going to continue that a little bit, as well as have a little bit of a look back so that we can have a good base for our work in graphing equations and solving equations by graphing. Long term, I guess it's not super long now because it's due tomorrow. Tomorrow is the journal prompt, don't forget that. And then just tonight's homework, let's see, it's 416, number 39, 417, 42, and 43. Like I said, those are not A, B, C, D type of problems. You just have 3 simple problems. Yes, Megan? Sure, yeah. Or I can get it for you. So, alright, so how about any questions on the POD or answers? Anybody get a chance to do that? Determine the slope and the y-intercept of the linear equation and graph it. Y equals negative 2x plus 3. You could probably fairly quickly tell me what the slope and y-intercepts are of that. If you remember the slope and y-intercept? Charlie, what do you think?
Negative 2 is the slope.
So slope is negative 2, correct?
And 3 is the y.
3 is the y-intercept. So to graph it, we would place a dot on 3 and go down to right 1. And that would look something like this. So slope is negative 2. The y-intercept is at 3. The point is 0, 3, which is right here. So this is the y-intercept right there. And then from there, I go down to right 1, because it's rise over run. And if it's negative, it goes down. Question 2, what is the slope of the line parallel to that? Y equals negative 6x minus 7. What is the slope of the line parallel? And if you remember something, it's actually not too bad. Yeah, Jack? Yeah. So the line parallel to that line, the slopes will be the same. Remember, because slope is just steepness, so the y-intercept kind of shifts where it crosses the y-axis, and the slope, if it's the same, the lines will be parallel. Very good. So how about questions on the homework? There we go. Any questions on the homework 2 through 8? 2 through 8 on section 9.5 on that handout. Any questions on that? Yes, Maya?
4.
So number 4 from the handout. Number 4 from the handout. 4x minus 5y equals 30. 4x minus 5y equals 30. And so I guess the question was, find the slope and the y-intercept. So do we have a little bit of a problem here? This is in standard form actually. So I want to move it into slope-intercept form. There's a lot of different things you can do. You can try to graph it and do other things, but my suggestion on this one is to put it into slope-intercept form, which looks like this. And when I do that, I've got some work to do. Remember we were saying, or maybe I was saying, that each of these, I think of them like as in their own little box. And what I have to do is I have to get y equals. So in order to do that, I need to move the 4x over there. I can switch these two around, 4x and negative 5y, all I want, as long as I stay on this side of the equal sign. As soon as I cross the equal sign, I have to use my math, like we're keeping the equation balanced. And so in order for me to get the 4x over to the other side, I need to subtract it from both sides, minus 4x. And now I have negative 5y left on the left, and I have negative 4x plus 30. Same thing. All right, so negative 5y equals negative 4x plus 30. And what's my last step that I need to do here? Just because I need to get y all by itself. Y. Yes, y. Megan?
Divide all sides by 5.
Everything, yes. By
-5.
negative 5, exactly. Negative 5 and negative 5. And the last part works out fairly nicely. the negative 5 divided by negative 5 is positive 1. That's why I just end up with y. So then y equals, and then on this side,
Positive
positive 4/5, because negative divided by negative is positive 4/5. Just so that you know, if you weren't able to remember that, graphing it would still be okay. You just go left and down instead of rise and run. You go down and left. So 30 divided by negative 5 is 6 negative. So I have my y-intercept and I have my slope. So I'm looking pretty good. I'm looking pretty good at this point. I don't think. Then use the slope and y-intercept to graph the equation. So 4/5 x plus negative 6. So I'm just going to do that. Y equals 4/5 x. I'm just rewriting it because I couldn't fit it on the last one. And I'm going to draw an axis. And so let's just do like the 5. So that would be 5, that would be negative 5. So I'll try to set this up. And now, where do I start? Class of math. Where should I start my process to graph this thing? Remember, there was kind of a set of instructions. Where should I start my first technical?
You have to go to negative 6, which is the bottom.
Right here about? Okay, good. I'll do that. I'll go to,
Make a dot.
I've got the dot. Dot made. Now what do I do?
Okay, now you go up 4 and over 5, and they're both positive, so it's going to the right.
Okay, so up 4 for the rise of a run, because that's what the slope is. So 1, 2, 3, 4, and then I need to go over 5, which is right over here. So it's right about there. And then I can do that again, if I want to, up 4 over 5. That'll be roughly here. And then I've got a pretty straight line. I mean, it should be perfectly straight if I had the graph there. So it is a linear equation, so the line should be straight. Well, I guess the line is straight no matter what. It's just by definition. All right. Questions on 8 or other problems? Otherwise, okay, class. Excellent. Okay. We're going to hit our notes now. So I wanted to do a brief look back at our, I guess, our fun with graphing. I like to think of it as fun. Not everybody does. So graphing. What did we learn first? What did you guys learn last year? You learned how to graph points. This is a review. So I want us to have a good base before we move forward into doing some other things. Okay? So 0, 3. What is that? I just wrote up 0, 3. That's random numbers, or how about this number? 5, 7, comma 7 in parentheses. What are those things? What can I do with that right there? Just those numbers. I can look at them, yeah. Yes?
You can put them on a graph, in certain spots.
Exactly. So these are coordinates, right? It's a coordinate. So up 5 over 7 might be somewhere over here, then 0, 3 might be right here. So these are just coordinates. They're points on this plane. This graph that you guys see and that you have on your notebook is graph paper, right? This is called the coordinate plane. This is the x-axis. This is the y-axis. And I'm hoping some of this will be like, oh yeah, I already know this. But I just want to, like I was saying, I want to get you back to home base so you have a strong foundation. So to graph things, this is the x-coordinate, that's the y-coordinate. I would go over 5 and then up 7, because that's 7 on the y-coordinate. Pretty straightforward, I think. So we also talked at the beginning of this chapter about using the function table. Do you remember we had a function like y equals 2x minus 7 or something like that? And do you remember we had a little table that I had you fill out, and it might have had 3 or 4 columns, probably 3, and I think you'll remember that I kind of use the same number pretty regularly, -2, 0, and 3. And then I put that number in there, and we got a point, and then we graphed it, because we would come up with these things called ordered pairs. And then the next thing we learned was using the slope-intercept formula And that's a little different, isn't it? And what I'm trying to talk about, the reason I'm talking about this is that some people get confused between these numbers, which are points on the line, and the slope-intercept form, which really doesn't give us it gives us points on the line, but it doesn't do it using the coordinates that we would normally use. So I wanted just to briefly review that before we move on. So next, graph y equals 3x minus 1 using a function table. So in order to do this, I'm going to draw my function table, and it's good that I have this little graph stuff here. Hopefully it'll help me keep the lines straight. And then I have my rows. Excellent. Oh, that's fun. Makes a fun little sound. So x, and then 3x minus 1 y. And then what do I do? What should I do at this point? Can somebody help me through this a little bit? Yeah?
So basically you just use small numbers,
Yeah.
especially because you're going to graph it.
Yep, exactly.
So like -1.
Negative 1's good.
Or 0.
What's our favorite? Yeah, my favorite's 0. I don't know about you, because it really kind of makes it an easy math calculation. And then let's just use 2. And then the last one we'll just leave blank because we don't really need more than 3 at this point. So what do I do next? Well, I just need to put these numbers into this function, y equals 3x plus 1, or f of x equals 3x minus 1. And negative 1 into there gives me is 3 times negative 1 minus 1. So 3 times negative 1 is negative 3, minus 1 is more negative. That's negative 4. So I have negative 1 comma negative 4. How about the next one? Does anybody have the answer for the next one and then the next one? Let's see if we can do that. Or just the next one first, and then we'll go after that. Yes? Good.
Okay, so you plug in 0 for the x and then 3x minus 1, and
Yeah.
you get negative 1 because it's 0 minus 1.
Exactly. Perfect. So there's another point, 0 comma negative 1, which is actually the y-intercept. Ah, surprising. It lines up with that on the slope-intercept one. So for the number 2, Anybody? Oh, yes.
Okay, so you plug in your 2 in place of the x, so it's 3 times 2 minus 1, or
Perfect.
plus a negative 1.
Exactly.
And then you get 6 minus 1, which is 5.
Awesome. So then I have 2, 5. Alrighty. So I'm just hoping that this is like so much review that you're almost bored. Because it should be. And I want to make sure that you understand this clearly. And so I probably need to make this on another graph. Oh, I'll extend the page. Let's try this. Here we go. So I have negative 1, negative 4. So let's see what I can do here. We have to make each of these squares worth more than 1. So I'll make each square worth 2. So negative 1, negative 4 means go left 1 and down 4, which is right here. Don't forget how to graph these things. 0, negative 1, what's that also known as? What's that little point called? There's another name for it that we use as slope-intercept form. What's that one? Charlie?
Wait, the middle?
Just this one right here.
Oh, the y-intercept.
Yes, exactly. Awesome. So y-intercept. Well done. So then over 2, up 5. So over 2, up 5, which is roughly right here. And I will get another line. Alright, if I can draw clearly. But that's all great. That's great. What would happen? What would happen if I just decided to not use? Okay, I've had it. I'm not going to use that. Let's see how that works. And I'm going to graph it using slope-intercept form. So let's see. The slope-intercept, it looked like this. Y equals.
This is so weird.
I know. Oh well.
Oh, try a different pen.
So y equals 3x minus 1 is the function that we just graphed. How do I graph it in slope-intercept form? It's a different method, I will say it's easier, right? I don't have to put in all these points. But what if I decide to graph it using slope-intercept? Where would I start this? Remember, like we just did it, y equals 3x minus 1. How do I start it, Conrad?
So you would start with the y-intercept, which is -1.
Oh,
So
already there. Awesome.
and then you go up 3 over 1.
Yes. Up 3, so 1, 2, 3 over 1. Wait a minute.
It's the same line.
It's the same line.
It's the same.
Isn't that just, it's kind of awesome. It should be. And I should be able to do this either
Saves
way.
work.
Saves work. I think that the slope-intercept form saves work. It does. It should be the same line. That's one of the, like, for me, it's a kind of an aha. Oh, now I see that there's some similarities in the way these things work. Okay? There are similarities. Okay, so hopefully this isn't frozen, but it is a test. Did that. Okay, so for you, the students, I would like you to try to graph something different. I'm just going to duplicate this slide. And then change that. Give me just a moment, folks, so that I can. Excellent. And we're back. So let's graph. If I can get it off of green someday, I hope everybody can see. Can you guys see that back there? Graph y equals -2 fifths. X minus 4. So see if you can do that on your paper. And you could either use a function table and get points, or you could use slope-intercept form. I'm just going to write or draw the graph right here. With the coordinate plane.
How many points do we need?
I just would do 3 if you're going to use the function table. If you choose to use the slope-intercept, you just need a couple. So remember, slope man should tell us what direction it's going to go. It's the left eyebrow. And slope man. So plus, minus. So we should know where it will go. Nice. So I'm just going to, again, each of my squares will be worth 2. So 1, 2, 4. So I will start down here at -4, and I'll draw a big, thick dot so that everybody can see it, including those viewers at home. And -2 fifths is the next thing. So what do I do for -2 fifths? Oh, I don't really like that much. I've got to go down farther. But we'll try. What should I do? What are my instructions? You guys, all you have to do is just give me directions. I'm just like a bot car that I am listening to your directions. So from here, from this point, running.
Go down 2 and then go to the right.
So down 1, 2, and then I go right 2, 4, 5, and then down 2, right 5. I can do that a couple of times and get extra dots. I can also do the reverse and go up 2, left 5. So I'm going to do my best to make a nice line here to make the linear equation. And that's it. And I saw some people's papers. You could draw the little steps if you wanted to, but you don't have to. It works out well either way. Alrighty. So, is everything frozen today for me?
Yes.
That's okay. So let's persevere. Okay, let's see if you can do this one. This is a whole nother level. I don't know if you're ready for it. Yes, exactly. On GAPS Math Game. The slope is a half. You're not graphing it, you're just going to write the equation for it. So it's a different way of presenting you with the problem. In slope-intercept form, and then in standard form. And I'll give you the hint that standard form is ax plus by equals c.
Wait, so would be C equals like when you do standard?
I use that is the appropriate way. So you'd have x first, y second, and then the constant term last.
Wait, what's the constant?
Just a number, like in this case, it's going to be -4 or maybe +4, depending on when you rearrange it. A constant is just something that doesn't have the x with it or a y with it. So, any suggestions for the slope-intercept? That one is a bit simpler than the next one, which I have to rearrange a little bit. Okay?
Y equals 1/2 x minus 4.
Perfect. So y equals 1/2 x minus 4. Now how on earth do I get this thing to look like something x plus something y? I've got to do the math of the equations. So I'm just big picture. I've got to move the 1/2 x over to that side.
What do you do after that?
Exactly.
You have to divide by negative because it has to be positive.
A has to be positive. So yeah. Do you know?
Okay, would you move or subtract 1/2 from both sides to get x's?
Yes. So y equals 1/2. Oops. Didn't do that too well, did I? Let me do that again. Sorry. Okay. So y equals 1/2 x minus 4. So in order to do that, y equals 1/2 x minus 4. And you said I need to subtract 1/2 x from both sides. And in order to do that, I can't combine the y's and the x's. And I'm subtracting, so I'll end up with y minus 1/2 x equals -4. Well, the y can be positive or negative. Is the order correct yet, or am I still have a little thing to do here? I've got to move the 1/2 x over. So I'm going to rewrite this over here. So I want to write it in x first. So negative 1/2 x plus y equals -4. And somebody just said the right answer a minute ago. How do I get rid of the negative sign on that thing?
Divide by a negative.
Yeah, I could divide by a negative or multiply in this case, -1. I multiply by -1, which distributes to all of these pieces. So it changes every sign. So that's 1/2 x plus -y equals +4. And that's it written. And if I wanted to get it to not be a fraction, is there any trick I could do? If I didn't want any fractions in this thing, is there something I could do so that I don't have any fractions? I could multiply by something. What do you think that would be, though? Yeah, Meg.
Could you divide 1 by 2?
Yeah, you could, but division kind of is a fraction maker. Because division is like a fraction. Yeah, right? What do you think? Multiply everything by 2. So 2, 2, 2. So that's x plus -2y equals 8. And that would be the best answer for this. X plus -2y equals 8.
Wait.
Yeah.
Oh, you multiply everything.
I multiplied everything by 2. And if I was able to change colors of this pen, I would, but it doesn't seem to be. It's not cooperating. Alright.
And when you cook something, it just goes back.
No. It's very annoying. Alright, but I'm gonna go to the next one so I don't get too distracted by the technology. Uh-oh. Here is the hardest problem so far. So, this is a little bit more difficult. Don't be alarmed, folks. The second point that I've given you was very strategic. So, the equation aligned through these points in slope-intercept form. I'm sorry, I did not say what kind and what form. But the slope you can do by, remember doing the slope, difference in the y's over the difference in the x's? That's my first hint. The second hint is 0, 7 is a special point. I'm just going to show you a rough graph of said point. 0. Ah, yes, exactly. So that's very useful in our quest to find this. So the first thing I want to do is find the slope-intercept. Has anybody done that? The first thing I'm going to do is look for the slope-intercept. Sorry, the slope, not slope-intercept. The slope. Remember the slope. I'll write it way over here on this. Uh-oh, can't see that too well. Slope is rise over run. So a difference in the y's over the difference in the x's. This is still new to me, folks, so I have to learn how to use all these things. So slope is rise over run, and rise is the y's. Remember you used to ask me, what are the little numbers underneath there? And it just means just do things in the same order. Be consistent in your subtraction. So how are we doing over here? Use this pen now. On this one, so it's, what do I do? I guess people are raising their hand. Yes, good.
Okay, so I did 7 minus 5.
Oh, cool. So you wrote this one. I was suggesting sometimes to write it on top of each other so that you can see the subtraction better, but you're doing fine. Yeah, you can still get it right. So 7 minus 5, so that's the y's, the y numbers. So 7 minus 5 over what?
0 minus negative 3, which is just 0 plus 3.
Yeah, 0 minus negative 3. I think on our quizzes, that was one of the mistakes that we often made, is it's the two negatives there. Don't forget those. Those are important. So 7 minus 5 is simply 2 over 0 plus 3, so that's 2/3. There's our slope, and I'm super close. I filled in one of the blanks here. Y equals something x plus something. The first blank is 2/3. The second blank is the y-intercept, and where do we have that? Where is that? Let's put these pins here. All right, where is the y-intercept? Yes, Nicole.
Okay, 7.
7.
But I have a question.
Oh, that's okay
But
too.
yeah,
7
7.
it is.
So when I was doing the rise over run
Yeah.
thing, I ended up getting -2 over -3, then leading to 2 over 3.
That's a great question because you subtracted them in a different order. That's just fine.
That worked. Right?
Negative 2 over negative 3 is the same as 2 over 3 because it simplifies to 2 over 3. Just the negatives cancel. Yeah.
How did you pull this?
Oh, great question. Because this point that I gave you can very conveniently is 0, 7. And 0, 7 is the y-intercept, which just happens to be b. It happens to be b. It is b. The y-intercept is b. Does that make sense?
Yeah.
Awesome. All right. We are really looking good now, especially on time and everything. Just this little issue here. It's okay, I'm going to persevere. I'll use the computer. Oh, let's see. Can you do it from the graph? See how you do it with this one. From the graph. We will have a quiz, actually this chapter test will be mid-week next week, so probably next Wednesday or Thursday or Tuesday. Is that clear?
Wait, the test is on Tuesday?
It'll be next week sometime. I need to test, I know, another week from now. I just need to make sure that you don't have other exams on the same day. So I'll make sure that,
Oh, yeah.
I think teachers, we like to kind of get an exam in before Thanksgiving. So the y-intercept, can you read it? I think it's readable.
Yeah.
I think it's readable.
I just like copied down the graph on my paper.
Oh, that's a good thing to do too. Conrad, you have an answer.
Okay, so the y-intercept is -1.
Awesome. That is correct. Right there. Perfect.
And then the slope
Ooh, that's harder.
is 2/1.
Yes. Perfect. 2 over 1.
And then the equation is y equals 2x minus 1.
Great job. That's an awesome job. So,
Wait, what about the 3? Wait, isn't it y equals 2/3
Wait.
x minus 1?
No, I think I did it
right.
nope, we're good. This is
Wait,
correct.
Oh, yeah. Where'd
But
you
let's
get-
just look at it. We can talk about it. Let's talk this through.
Where'd you get -1?
Where? Oh, because the y-intercept is right here.
How do you know it's right there?
Because
Can
the
somebody-
line, the bold
How
line,
come?
Oh,
Why do you think?
the bold line, and
So-
that's the
I
y.
get it.
So this
That's
is the y.
Whoa.
So anything, any line crossing that is the y-intercept.
Okay, okay. That makes
So I think that it's funny too because Megan is saying that she gets it now, but I think all of us sometimes are, so half of us might get it. You're just the one that's saying now suddenly I get it. But a lot of us might not have realized. Remember, this is the y-axis, and it crosses the y-axis there, hence the name y-intercept. It's a good name for it. Great name. And then the slope from dot to dot, I had to go up 1 over 2. Or you could think of it as you could either go up 1 over 2 like that, or you could say, oh, I went right 1 up 2. But as long as you did, you could write 2 over 1, rise over run, and the end is fine both ways. Awesome job. Okay, so our plan, let's see what else I have in store. And then if we have time, it'd really be nice to get some work done in class. But I think one more. Yeah, this is the one. This is the one that I was building up to. Let's see what it's asking us to do. Write an equation of the line that's parallel to the line y equals that passes through the point 0, -2. Remember what I said when you read math problems? The first time you read them, just read them all the way through, and it might not make any sense. Then start making sense of it. So look for little pieces that are important. Write an equation. That's what we've been doing pretty much all day. That is parallel. So in parallel, something in my head should be saying, when it's parallel, something to do with the slope. Okay, yeah, the slopes are the same. So I'm just trying to tell you how maybe it would be a good idea to think of a line that's parallel. Okay, so, and I have the slope right here. So I already know the slope is parallel. And then passes through the point. I'm still a little confused about this. So let's kind of just keep going. I'm going to forge ahead. I know I want to write it like this. mx plus b.
But don't you already have like the real thing? Couldn't you just write y equals 2.5x minus 4? Because that's like the same.
Very, very close. So you are asking that y equals 2/5 x. Okay, I'm going to stop there because for sure this is right, this component of it, because I know that this is going to be parallel to this line. Because parallel just meant what? It just has to be the same slope. But it can't be the same line
So
because
just change the y-axis.
so I need to change the y-intercept.
Yeah.
So normally if I just came up with a random thing, hey, just if this second part wasn't here, you just throw in any number you want, as long as it's not -4, because otherwise then it's the exact same line. I could put in +6, +27, -100, whatever. I just know that this is going to be parallel now. The second little fact that I had to match up with or work with is that it needs to go through this point. Do you notice, again, I've given you a point that's super good and important. -0, -2.
Oh,
0,
so
-2. So what should I use for the y-intercept? What we say?
-2, because that's the y-intercept.
Yeah, so that's the y-intercept. Because I gave you the second point, just basically said, this is like saying, with the y-intercept as -2. But it's just a different way of saying it.
But this is what the line would look like that.
The line would look like 2/5, so up 2 over 5. So it'd be slope, man, again, it'd be something like that,
Okay.
plus or minus. It's hard to do with these giant graph squares.